we'll pick up here at question 21. Now, you can use the substitution method, which would mean you would solve one of these like this second equation, solve it for x, and then plug that in. So that's a method. I'm going to show you another method using the Desmos calculator, using the graphing features, where these are two linear equations, and what the solution is it's going to be where these two intersect. Okay, so let's go ahead and pull up the Desmos calculator right here, and all we have to do is type in the equations just as they are. So we get 2x plus 5y equals negative 22. It's as simple as that. As long as we can enter the equations, go to click, we're going to add an expression, and the second expression, second equation, x minus 6y equals 23. Now all we need to be able to do is be able to see where the intersection occurs. So make this nice and big here. Let's clear off what we've got going. And Desmos is nice. All we have to do is point at the intersection, click on it, and it'll be frozen there for us. -1, -4. That is the solution. That is the place where these two linear equations cross, where they intersect, where they meet, where they are both satisfied by the same point. The point -1, -4 is on both of these lines. It satisfies both the lines, and it's the only point that is on both those lines. We're done. So all we have to do now is enter that. Highlight it. It's -1, -4. So we come back here. What is the solution? -1, comma, -4. Submit it, and we're good. So when you get to this question on the final, let's just use Desmos graphing. You will have access to that in the testing. There'll be a link provided for you. So just click on it. It will open up the Desmos calculator for you, just like we did here. You'll see it in a tab, and you'll be able to pull it up, enter in the equations, and get your answer. 22. What do we have going on here? A day at the amusement park. Now what we're going to see is this is a similar type setup, actually, only we have to be able to make the setup. Okay, so let's get our pencil going. So we've got a admission fee at an amusement park, $10 for children, so that's important, and $14 for adults. And again, we look down here, this is going to help us with our variables. We're looking for how many children there were. There were so many children, and there were so many adults. So we're going to have two variables, and we'll use x and y because that's what we'll be graphing with, and we just need to set them up. So since down here we're looking for the number of children, x is the number of children, and y will be the number or amount of adults. Now you could use A and C as well, but we'll go with that. Okay. On a certain day, 342 people entered the park, so that's the total amount, and they collected $4,100 in fees. So then from this, how can we do it? Well, we know the people that entered were either a child or they were adults. And where's the cutoff point? Well, different people have different things, but whatever the rules are for how old a child is, and then when an adult is, that'll be set. But we know of the 342 people that came in, they were either children or adults. So if we add the children and adults together, we know the total is going to be 342. So that's one equation. The other equation is we know the total amount that came in, that we park received $4,100 in income. For each child someone had to pay $10 for them, so that's going to be 10x. And for each adult, $14 was paid, so 14 times each adult. So we've got a second equation here. Just like the last one, we just need to find where do these two equations intersect. And we can do it in exactly the same way. That's why I really enjoy using decimals. Okay, so we're going to pull up our decimals here. And what I've done is I've made it kind of writing over, but I've made it a little bit smaller window, which you might not be able to do with when you're using the lockdown browser, but you would hopefully have a piece of paper where you could write down your equations on, and then we just need to be able to enter them in. 342 is equal to x plus y. Now we don't see a line, but notice that, look at our window. We're going from 0 to 15, that's the y, and 0 to 10. So these add together to be 342. So what we're going to see is we're going to need to zoom out our window, and then I'll kind of erase this stuff once we get this going, and then we'll just be able to fill it in. This equation, 4100, is equal to 10x plus 14y. Now we could enter it the other way around as well, but and notice we don't see anything. So what we're going to do, so I don't move some stuff around. We're going to do I'm using my mouse wheel, or you could use the plus or minus. We could zoom out until we see it. See, we see the intersection here. And so again, this will zoom you out, zoom you in. Just you see the intersection. 172 is the x, 170 is the y. So we can go ahead and write that down. Bring my tools back out. So what we have is the solution is 172, 170. We'll write that down. Remember, this is the x, this is the y, this is the children, or the number of children. And this will be the number of adults. Very straightforward. We'll let's this one, shoot that down, and again we just need to enter it in. 172 for the children, 170, about equal. Some adult brought a extra child with them, but otherwise there was some pretty good adult supervision going on. And see, we've got it right. So again, this one really is setting it up correctly and, pulling out the details, getting the equation set up, graphing them, we'll find the intersection. Excellent. Let's move on to 23. Now, this time we're going to be asked, we're given a linear equation. Notice all of these are, we're given some in linear equations, some are exponential. Sorry about that. So we're going to explore down here. Remember, with linear equations, in fact, let me adjust this maybe to medium, are going to be y equals mx plus b. Exponential, those equations are going to be y equals a times b to the x. So that's how they are. Remember that for linear, the rate is here, so a positive slope is going uphill, a negative slope is going downhill or decreasing, and then this is our y-intercept. For exponentials, what we do is we take whatever b is, and we subtract 1 from it, and that'll give us our rate. Again, this 1 is like 100%. You think of these as percentages that we get. So a negative rate would be a decrease. So this gives us a rate. So a negative r is a decrease. And a positive r be an increase. There we go. So as we go through this first one, g of x, it's negative 16. It's got to be decreasing. It's over here. It's decreasing. There is no exponent here. It's a linear equation. So that's the other, we can see the exponential will have the variable will be up in the exponent. There's another f of x. There is no exponent. This has to be linear. And it's positive. The slope is positive, so it is increasing. D of y, we see that y is up. The variable is up in an exponent, so that is definitely exponential. And the b is 3, so when we take 3 minus 1, so take the base, right, minus 1, we get a positive number. We get 2, which is positive, so that's an increase. I should say not negative rate, but when the rate, so what we're looking for is if r is less than 1 or 100%, right? This is our decrease. And when r is greater than 1, we have an increase. I just had to do the subtraction one time to figure it out myself. Okay, there we go. So it's the exponential, and it's increasing. 1.25. Actually, I was right the first time. Okay, we'll start this one.